Consider a transmission line of characteristic impedance of 50 ohms if it is terminated by at one end by 50 ohms, Z50 ohms and capacitive reactance of Z50 ohms. Then VSWR in cases of A and B and C. That is, completely VSWR depends upon the magnitude of the reflection coefficient, that is 1 plus rho by 1 minus rho. Rho is nothing but magnitude of the reflection coefficient, that is ZL minus Z0 by ZL plus Z0. So in the case of first, it is a matched one. So the reflection coefficient is going to be 0. So VA, that is voltage standing wave ratio in case A, that is 1. So if it is terminated with J50, rho is equals to J50 minus 50 divided by J50 plus 50. So it is going to be J1 minus 1 by J1 plus 1, whose magnitudes are equal denominator. So rho is again 1. So the VB is equals to infinite. The voltage standing wave ratio is infinite. Similarly, in the third case, that is whenever the transmission line is terminated by minus J50 ohms, rho is equals to minus J50 minus 50 divided by minus J50 plus J50. The magnitude is again equal. So rho is again 1 in the third case as well. So S is infinite. So the voltage standing wave ratio in both the cases, that is whenever the transmission line is terminated with the J50 as well as a capacitive reactance of J50, that is minus J50, in the both cases the voltage standing wave ratio is infinite. That means VSWR in both the cases are equal, whereas in case of A, that is equals to 1, so which is less than VB/VC. That is option D is correct. The following network, find the S matrix. Here S11 is 100 minus 50 divided by 150, which is 1 by 3. So S12 is given as S12 S21 is equals to 2 times 100, that is 100 divided 200. See, this is 100 by 150. So 2 la 3 ja, so 4 by 3 is the perfect answer. So similarly S22 is also equals to S11, hence option A is correct.
Value of the determinant ABC, MNP and XYZ is given as K, and we have to find the value of the determinant 6A, 2B, 2C, 3M, NP, 3X, Y, Z. Let us use properties of determinant. Now what I do is I'll take 3 common from the first row, so which can be written as 3 times of 2A, M, X, 2B, N, Y, 2C, P, Z. Similarly, we can take 2 out of first row. So 3 into 2, then it will be A, B, C, M and P, X, Y, Z, which is nothing but 6 times of K. That is option D. We have to find the probability of guessing 6 questions out of 10 in an examination if each question consists of 4 options. So if each question consists of 4 options, there will be only one correct answer. So probability that the answer is correct is 1 by 4 and the probability that the answer is wrong is 3 by 4. We have to select 6 questions out of 10. So the total number of questions are 10 and we have to select 6 questions. Exactly 6 or more. So we have to check P of X greater than or equal to 6, which is 10C6 into 1 by 4 raised to the power of 6 into 3 by 4 raised to the power of 4 plus 10C7 into 1 by 4 7 3 by 4 cube plus similarly 10C8 10C9 and 10C10 1 by 4 raised to the power of 10 3 by 4 raised to the power of 0. If I simplify, the value will be 0.09, which is option B.
Following is not valid CDF. CDF is nothing but a cumulative distribution function, which is nothing but a probability distribution function. Here, probability distribution function is monotonically increasing because it is the probability of events, so it is monotonically increasing function. See, if we observe this property in the given figures, option A is correct because it is increasing, it's not decreasing anywhere else. Here comes to option B, the function is decreasing and then after increasing. So option B is not a valid cumulative distribution function because it is not satisfying monotonically increasing property of the distribution function. So option B is not valid CDF. Consider the matrix P, which is given as -3 1 -2 0. The value of EP is. Here find out the transition matrix E power PT and substitute T equals to 1. E power PT is nothing but Si minus A, Si minus P whole inverse. Okay, inverse Laplace transform. Then we will get option as D.
We have to find whether the integral 0 to 1 dx by x square plus root x converges or diverges, or whether it is oscillatory. We can write this as 0 to 1 dx by, I'll take root x common. If I take root x common, it will be x root x plus 1, and this can be written as 0 to 1 dx by x power 1 by 2 into x power 3 by 2 plus 1. This can be written as 0 to 1 x power minus 1 by 2 by x power 3 by 2 plus 1 into dx. Now clearly if we integrate this, it will be a constant value. Let us suppose some k. You can substitute x power 1 by 2 as some t and you can evaluate the answer. So it will be a finite value that is constant. So it converges to A, option.
Average response rectifier type electronics AC voltmeter has DC voltage of 10 volts, okay, which is going to be applied across this AC voltmeter. The meter reading will be, okay, he has applied DC voltage of 10 volts. Now what type of voltmeter it is? It is having AC voltmeter. That means always this voltmeter read RMS values. Now what is the RMS values for this one? 10 volts is the answer. So option B is the correct.
MOSFET is to operate at ID equals to 0.4 milliamps and GM is equals to 1 milliamp per volt if K dash is equals to 50 microamps per volt square. Then required W by L ratio is. Here we are neglecting a channel length modulation, that's why lambda equals to 0. So ID is equals to 1 by 2 K dash W by L VGS minus VT whole square. Now here we know, in order to decide W by L, we have to know K dash. We know ID, we know K dash, we have to know VGS minus VT. So if we are able to express VGS minus VT in terms of the known parameters, then we will be able to calculate the W by L ratio. So GM is equals to 2ID divided by VGS minus VT. So VGS minus VT is equals to 2ID by GM. This is this. So which is 2 into 0.4 divided by 1 milliamp. This is milliamp. So this is gets cancelled. 0.8 volts VGS minus VT. So 0.4 is equals to 1 by 2 50 into 10 power minus 6 W by L and 0.8 square. If we solve this expression, we will get W by L ratio, that is aspect ratio, is nothing but 25. That is option C is correct.